to a new building, and that has a huge impact actually, and that's a lot of work and preparation. And I believe that's has been done in different places, different sites. They were trying to find a solution if we would like to move from one place to another, and what we have to start, what we have to do, infrastructure. You know, there are a list of things that will not finish when we are talking about moving one site from one place to another. Just imagine moving a house and how much you have to move things, I mean, from one place to another. But in case of a research center like CSCS, I think that's more complicated than that. So we're going to talk about part of it, one part of it that we'll be covering, and how we you know, simulated it, evaluated it, and just picked up the right, we believe, the right solution for us, which is one of the availables in the market. So yes, CSCS is moving, and the move is not like 100 kilometers. It's not like 100 kilometers, 300 kilometers. So we were lucky that we had the distance is not far away. So we are moving from a small town called Manno down to Lugano, which will be close to the campus, the university. It is like a distance of geographical distance 3 kilometers. And the dark fiber is 10 kilometers. This is what the guys from Switch just informed us. So I never measured them myself. But for the road distance, yes, I did. And I did that in Google, actually. And this is what it gave me. So there are different roads, and it's like 6.7. So here is the old building, and here's the new building. And you know, it's just a little bit up and down just to reach down CSCS. So, you know, if moving is like this, that will be great. You know, but it will never work like this, you know, holding everything and moving it. So that's possible for a lot of things at CSCS. Maybe networking, power off, moving things, switches, supercomputing system, a lot of clusters. But when it comes to data, there's a big question mark. And there are a lot of philosophy about it. I mean, I've been looking and for different sites, what they did when they moved from one place to another. Powering off, moving, you know, just powering off a rack of disk and powering it on again. Just imagine, there are some studies talking about 5 to 10% of the disk will not show up. They will die. And that means you whatever kind of file system you have, whatever kind of rate that you have, it's done, it's dead. So before you move it, just think about such research and such study before you do it. I really like this photo here. I mean, this is a wonderful collaboration between everybody. Also, this guy is doing nothing actually, you know. But yeah, exactly. Okay, so copying and moving. You know, replicating things, copying, moving. Tapes the same situation. Well, it's safer than disks, but still, you know, copying in USB keys, I think it will be difficult. Backing up to tapes, that could be just for security, but still, you know, losing a tape or 2 or 3 tapes, you know, without replication inside the tapes could be an issue. You know, that could be just destroying one project, and that's very harmful for us. As I mentioned before, powering off and on is just something that we had to disclose directly, completely, because, you know, we learned from what others did, and we don't want to make the same mistake. So moving data online. That's this is the major things that we tried to look at and see how we could do it. But before we just pick up the right solution, we had to think about, okay, what kind of data we have, what kind of network, what kind of systems we have. You know, we start looking at file systems again. We start looking at the number of files, how we could move them. The network connections that we have between both sides, the interconnects behind it, how I'm going to access it from both sides. Interruption, you know, CSCS, we have a lot of service that has really dependency, and we cannot really power off the system for 2 or 3 weeks and says, okay, guys, you know, we'll be off for 2 or 3 weeks. We have the climate, meteorology, and they will just really shoot us. And there are a lot of critical projects that should be always available. Timing and dependency. I mean, you know, take down your file systems, you cannot do anything. Full stop. Take down the network, you cannot do anything. So all this has huge dependencies, and we had to look for every point here just to be able. Really, it's a puzzle, and we had really to think about every part of it to see how we could do it. So still, I mean, it's always related here, and this is every time we try to avoid talking about data, I find myself talking again at data. So if we're talking about network, I will be, following again data and see how we could just deal with it. I've showed it yesterday. Actually, this is a global file system. I mean, just very fast. I don't want to repeat it myself, but here you can. That will give us a little bit, some information about the kind of network. And this is we're talking about the QDR. That means we have to find a way to work at the QDR on the IB network and see how we can connect using the Infiniband. Here I'm talking about Ethernet. This is for the management, and this is for us is not doable, so we had to think here and see how we could just move online using this part. So again, these are the numbers, 1 petabyte of data. That's after really cleaning, contacting the users, try to clean as much as you can, remove the things that you don't need them, try to help us in this movement. But this was not very helpful because we had like 20 millions before, and this jumped to 33 millions or 35 millions I mentioned yesterday. Also that went down from 1.5, let's say, to 1 petabyte, but that increased. And that was a little bit not very helpful for us. This is a version that we're using on GPFS and the network. Okay, this is another file system. I will stop a little about it, talk a little bit about it. This is recently we installed it. We did this work with DDN. This is a 3 SFA 10K using also the IB network. I mean, the good parts about it is that we start using here the TMS SSDs for the metadata part. And the kind of connections here, with SSDs, fiber channel was enough for us. The rest is going over the IB. We did a lot of work here for during the acceptance and trying to get the best number. This is through this is a DDN system that went through IBM, so we got it through IBM, and we did a nice collaboration here. This system showed good numbers. I mean, just in acceptance with 1 megabyte of block size, we managed to get pass, which was the requirement of the acceptance, 20 gigabyte per second. We passed it roughly 20 gigabyte 0.8. But when we just used the 4 megabyte here, we hit the peak of it, which is 33 gigabyte per second of the 3 systems. So 11 times 3, and that was, that was a good number actually to see on these systems. So this is again another file system that will be running. And this is, I'll talk about 2.7 petabyte here. We did not have before, so now we have a new system. That means that's always be just loading on the network, and that we have to move. So we had to divide these systems, get one of these down to Lugano, that's the plan actually, and keep these 2 systems, and then try to just to connect them, move data here, and then move the rest down to Lugano. Okay, this is the CSCS IB network at the moment. So these are 2 5100 QDR switches, and this is internally the switch itself, so it's just pure factory, and the rest of these switches are 36 port QDR. Now we have just recently added some of the FDR switches actually, and for testing purpose and trying to see, trying to get a little bit integrating FDR little by little. So we stopped buying QDR, and now we're just getting the FDR and adding it to the system. But the main one, the 2 big ones, are still these 2 switches. This one here, I believe this is wrong. I mean, just connected this level. So this is usually just go at a different level here, but missing some. We are still missing some switches, and just adding the top of switches to be able to keep the factory clean. While these ones are systems that stand alone, interconnects. It's using IB2. Okay. So there are, as I mentioned before, there are multiple of systems available in the market that allows us to connect, IB network, or let's say extend it between for certain kilometers or miles. And in this case, we picked this solution. Also, it is based on each box. This will be delivering the SDR connection, but there was a purpose of doing that and not getting one box that will deliver the QDR. So to talk about first the link between Manno and Lugano, we have a dark fiber link that allows us with I'm not an expert in the optical part, but allows us to go for 4 colors, which is each one is 10 gigabit. In this case, we have 40 gigabit dark fiber from Manno to Lugano. And as I mentioned, other solutions are available that will allow us to connect these 2 sites with 1 box and using QDR. But there are multiple of reasons. Just try, step back and say, okay, no, I don't want to get 1 box set. Do that for balancing and for high availability reasons. And that's why we picked this one, because each one this will be delivering SDR, and that you can multiply that by 4, and then we'll be just getting the QDR. So in our case here, we needed 10 kilometers, and that was what covering this one, the basic one. This one could be just exceeding that. I know that Obsidian guys are here, and they can just talk more about it, but there are just more than 1 version that we could just exceed more than 10 kilometers. I know that's 80 kilometers available, 300, and so forth. RDMA support, so we are not limited to the TCP/IP. And there are some products available at Mellanox X, and that was the routing between, which is handling the TCP/IP only connect. Go over Ethernet and just allow us to go this way. But we wanted to go beyond the TCP/IP, since we use RDMA level at the GPFS and using iVerbs. That's why it was essential for us to use the RDMA here and just going for the high availability. So if I lose this one at any moment, I want to continue. I don't want to have any interruption. And that's why we went and we tested all these parts, trying to verify, if this could answer us. And really the guys of the Obsidian, they were very helpful. So we sent them many comments asking, how you could just solve this issue, how we have these questions, and they were very helpful. They did not have the direct answer, just really they were very flexible to involve other people and trying to get some comments from other people to help resolve this problem. So this is a test case that we did it between. Let's say it's here. Let's imagine that this is Manno and this is Lugano. In reality, they are not. They are just both of them in Manno, but we have in the middle here a 10 kilometers of fiber cable. So we did not go around in CSCS passing these 10 kilometers, but they were just boxed, and we had just an input and output for 10 kilometers cable, fiber cable. And this is exactly more or less the case. Now, in this test here, we're talking about the 4 Obsidian, the 4 times SDR Obsidian, and the same from the other side. And we have the switch here and the switch here QDR. And 2 nodes in this side and 4 nodes in this side, where we have some disks here. And we went for different phases for testing. So we went for a file system that just taking this part and this part, and then we moved the disks from here to here and make it one file system here, accessing from clients and try to measure that. And then we start moving the NSDs from here to here, because they through the fiber channel, all the nodes has access to them. So we start deleting the NSDs from here, while we had NSDs here and start deleting here and migrate them to here. That was online without any interruption. And all went successfully. There's a distance 10 kilometers. That means we have a latency. But in a GPFS, latency is something that's not fundamental. Okay, that could be an issue if we are running some, MPI that's based on RDMA, but not the case if I'm using GPFS and moving all the NSDs. So we had no interruption. We had some drop in the performance because you are getting, we're moving from one side to another. But, part of it is that we are up, we are running, we are moving data online, and there are no interruption, and the work will continue to do it. So these file systems, the way that you are using the global one, they are not a scratch file system, they are not a spooling directory where all the jobs of the HPC systems are running at. These are where we store data of different projects, where users, they have tons of data there, but it's not a working and a spooling directory. So the number of, I think the weak point of our test is the number of nodes. And to be honest, I had 6 nodes only at that time. So I think that was maybe the weakest point where we had to get more nodes. But at the end, we managed to get the maximum from it, and we got the number really announced. So I'm talking here about 4 times SDR. I got the QDR exactly, completely. There's no chance. I will show some of the numbers. GPFS worked in both sides as if one file system. That means in both cases here, I have only one OpenSM. So it was managing these 2 parts of the subnet as if it is one subnet. It did not complain. It did not recognize any issues, any problem. It just saw everybody from these sides, and then we went for benchmarking. So we used different tools for benchmarking and trying to evaluate it. So we use the OSU benchmark here. We use also the tool that offered by OFID, like measuring latency and measuring bandwidth over RDMA. Then we went to the IP part just because that could be important for us. And finally, just adding and removing all these NSDs. And by the way, this is the range of IP that we are using between both sides, and yeah, that worked. So these are the RDMA bandwidth results, and we just wanted to measure that and compare it between a standard switch, put in a couple of nodes, test it, and then just go over the Obsidian and test it. And you can see here, this is a peak that you can get it now with QDR, the limitation of the PCI Express Gen 2 or the encoding, and this is 3.2 gigabyte per second. And here I can see like roughly 900, let's say, megabyte per second. This is one link, and this is multiplied by 4. So we are at like roughly the same bandwidth. So we're just getting the maximum from the SDR. Now here we will see a little bit more than this link, because here we are limited the encoding, and that will not have it, between these Obsidians. So we are talking about 4 times SDR, that each one is real 10. And in this case, we are talking about a 40 gigabit, not a 32 gigabit. And this is a test we use for the for latency, just to measure between both sides. This is what we will getting, if you run it on 1.27, 1.3 microsecond of latency. And here we are talking about 52, let's say. And this is I'm talking about the distance, 10 kilometers. I mean. And that's the number. I know that recently they announced that they managed to get a speed more than light, but in our case we are still respecting that part. Okay, so here are just some numbers of the iPerf. 7.89 gigabit per second. I think I got better numbers there with this test. I'm just trying to put more threads, and that has been. This is an old one. This is the one that has been announced in the papers, because we had a paper concerning the Obsidian. We published it. And I got later better numbers, but was too late because the paper was out and I did not want to change it. So from the IP point of view also, that we got also good numbers. And then we went to GPFS. Beyond adding and removing NSDs and trying to guarantee that we are getting the functionality part, just we wanted to test it at the GPFS itself and trying to get some good numbers. Now one of the tests that we wanted to guarantee is that when I'm doing some load and just whatever the reason I unplug one of these Obsidian, what will happen? And we have seen that performance will drop, but everything will continue without any interruption. We did not notice anything. So what we did, we have 4 links, and we start pulling one after the other and keeping like a delay time of 1 minute between every unplugging one cable while the run was going on. And you start seeing that these were just going down, and then you plug again the cable, and then things will start coming up again. So just until you get this number, you'll get roughly 400 something megabyte per second. So that could be improved, depends on the tool that you are using for measuring on the GPFS point of view. If you could run, I know that Obsidian guys, they just gave us something that similar to, let's say to copy data from one side to another, but that works in parallel, and that could be giving like really a huge difference between what you could deliver. It could sustain the network, could really hit the peak of the network, because it's just working in parallel and they are doing a lot of developments. And that was very interesting tool that we got it from them just for testing purpose. And I believe that maybe during this year we'll just be coming out with some paper concerning that part and showing that the tool, how much it improved it, not only in the network itself, but over the Obsidian too. So the high availability part, it just went very well in pulling out and in the cables, and then just restoring the links for the 4 of them and getting the peak again. And there was no interruption at all. And that's the point that we wanted to see to avoid any interruption start in the phase of moving the data from one NSD to another. This is using some loads on the GPFS perf here. So we can see here, this is the 400 something. You can see some interruptions here. It's not related to network. This is the GPFS perf itself. And so that product is very interesting. But here I'm just going to look at one part that we have seen it, and from the network point of view, just think about it. That could be, let's say, could be an issue. I'm trying to solve it. Depends on the layout of the network, which I started at the beginning saying that from the network point of view, you need to really understand what do you have and how do you connect it. So here we're talking about the real fat tree and the routing algorithm in fat tree. Now connecting these 4 boxes to a system. By the way, I had a discussion with the Mellanox guy to confirm everything I had, because and that was very helpful for us to really to how to finalize this end, especially from and how to treat these. So these ones will be treated as switches, 4 switches. That means these 4 will be just sitting here, as if they are just at the same level of these switches. And these connections will go to this level, at these top 2. Now, when I will connect the cables and go down to this level, then what I did, I put one more level down here. And that means I broke the fat tree. And again, I put another switch to connect the systems down on Lugano. That's again, I went one more level down, and that also broke the fat tree. And if I use a fat tree algorithm here, I could routing, that could be an issue. So there's this semi-fat tree algorithm, which would be the up-down, that has been confirmed, actually. I just also had a discussion with Todd concerning that the up-down could solve this problem. Now, I know that there's another OpenSM, which is, let's say, 2nd generations coming out from a collaboration in the community with Obsidian and others, that could handle, more than one, okay, 5 minutes, okay. More than one routing, let's say, more than one topology connected to each other, where you can define part of it as using certain routing algorithm like fat tree, and the other part, although they are connected at the same topology, could be using a different routing algorithm. So this is very interesting in such cases to be able to solve such case, because here we had to change that. Instead of going to mini hub or fat tree, we had to go to the up down. And by the way, up down is really good. I mean, helpful, because it solved it will just solve this problem here, but solve other issues that we had on the mini hub. And that's what I mentioned, the points here. But okay, the load balance, we talked about a certain number of nodes. So and to load balance between all the links. So just, with such number of nodes, if 2 of these nodes will be talking to one node, or how many links you're expecting to use in such connection? I mean, maybe it's a question to the network experts here. I have one node from one side talking to other node, and I have in between them 2 switches, and there are 4 links between the 2 switches. So if one node talking to one node, I'll be using 1 link. So if I have 2 nodes talking to one node, how many links I'm going to use, and which links I'm going to use? Todd? It's exactly destination. So in this case, 2 nodes will be using the same link to the other switch, and in this case, we will not be load balancing it. So I'm not going to use the 4 links. I'll be using 1 link only, and that was a problem in the number of nodes that we have. That's why what we did, taking that 4 nodes, and make them the destinations and start running from the first 2 nodes to hit the last 4 and found that I was using the 4 links. And that's why we have seen it here that all of them, they were in use because the destinations were just 4 and they were different, and this is how we load balance it. So the number of clients and servers should be just enough should have enough links, enough destination routing to be able to balance all of them. Otherwise, we'll be ending using one part of it, and that could be a problem. And this is what we talk. I think that we'll hear some of them. I think in next talks through Obsidian, we'll be hearing about this one, and I'm just very excited to hear more about it. And I believe that we will be looking to work on such OpenSM. This is one of the hints that the LMC just set it to 2, so it's allowing for links for HCA, and that could be interesting in the load balancing. Finally, I would like to thank especially Chris Gamboni. I mean, this is CSCS network manager. He did a lot of work with me. Stefano Gurini, he presented yesterday storage. He did also a lot of work from the GPFS too. And Thomas Schoenemeyer, that he's first my boss, and second he's really helping a lot, doing a lot of work, good job when what comes to papers and before publish it. So just having his touch on these papers is always excellent results. Questions? Thank you. This is a question? Yeah. Okay. So, yes. Okay, so we moved them. Let's say, okay, we bought the system, we moved them, everything. Now, at CSCS, there are a lot of projects, especially when it comes to storing data in different locations. I mean, we talked yesterday about the water and what happened in India and in Thailand, and what happened to the disk and what flooding water and disasters. And I think that there are some. Let's say we are thinking about just having a link between more than one site for storing data in different sites. And I think that will allow us, such solution will allow us to continue and creating a link over IB from one site, not only for the phase of moving from one place to another, but also for just keeping another copy of a very important and critical project in other sites. And I think that could be here an advantage for creating such link. Thank you.